and the integration of cutting-edge technologies in our technical education ecosystem. The theme of this FDP, additive manufacturing in the context of Industry 4.0, is of paramount importance in today's rapidly evolving technological landscape. And it is a disruptive technology with the potential to revolutionize product design, development and manufacturing across various sectors, including automotive industries, healthcare, and aerospace industries. Our goal is to equip faculty members with the knowledge and the practical insights needed to integrate these advanced concepts into their curriculum and foster future-ready engineers. We are fortunate to have with us a panel of distinguished resource persons and experts from different fields of additive manufacturing, who will be sharing their invaluable experience and insights over the next 6 days. And will be engaging in stimulating discussions and explore the latest trends and challenges in additive manufacturing and Industry 4.0 concepts. This program is designed to be an enriching experience, a platform for collaboration and knowledge exchange, and an opportunity to stay ahead in the world of advanced manufacturing. I request the participants to utilize this opportunity to learn, innovate, and contribute to build a stronger ecosystem for additive manufacturing in our nation. I wish you all a very productive and inspiring FDP. And I thank our principal, Dr. CLV R.S. Prasad Gauru, for his continuous motivation and support to conduct this kind of programs in a successful way. Thank you, sir. And I thank all the participants and wishing you good luck. Thank you very much.
Thank you, sir, for sharing your valuable thoughts. It is now my privilege to invite Dr. CLV R.S. Prasad, sir, Principal, GMR Institute of Technology, to address this gathering. Sir's vision for academic excellence and continuous learning is truly inspiring, and we are eager to hear your thoughts and guidance. Please take the virtual stage, sir.
Thank you, Ashrita. A very good evening to all of you. At the outset, I'd like to thank AICTE for continuously supporting GMR Institute of Technology by sponsoring the faculty development programs. And as rightly said by Dr. Shashi, this is the third program that is being sponsored by AICTE. And I'm sure that all the faculty members are utilizing this opportunity and getting more benefited. And coming on to the topic that has been chosen for this today's faculty development program, that is the role of 3D printing in Industry 4.0. I think everybody must have realized that 3D printing, or I mean to say that additive manufacturing has led to a great revolution in the manufacturing industry. So it has completely triggered the additive manufacturing typically, and also the rapid prototyping. Rapid prototyping is that which is more influenced for the innovation. So for rapid prototyping, additive manufacturing is a key aspect, and I'm sure that all the developments that we had in this additive manufacturing and 3D printing has added a lot of value. And it has gained a lot of importance in the typically in the manufacturing sector and the innovation sector, health, and also in the lifestyle. In the lifestyle sector also, there are a lot of things which are coming by this additive manufacturing. We all know that Industry 4.0 is the key features are IoT, cloud computing, and then your cyber physical systems and so on. And now that adding to this, this additive manufacturing, the other way called as 3D printing, will completely revolutionize and also it makes a pathway for the mass production in additive manufacturing. As of now, additive manufacturing is not taken as an aspect for the mass production, and I'm sure that its influence in Industry 4.0 will always lead to the mass production. And there are, yes, there are some challenges in additive manufacturing, that is in 3D printing, typically for the surface quality. And I'm very sure that there are a lot of researchers who are working on improvising the surface quality of the components and ultimately leading to the quality of the production, and also having the sufficient mechanical and physical properties. I'm sure that all the sessions that are there added here for this FDP will definitely enlighten and enrich the knowledge of the participants about the additive manufacturing and its influence in the industry 4.0. And also, I would like to thank all the resource persons who have readily accepted to be a part of this program and contributing for this. And particularly, I would like to thank today's chief guest, Sri Shreyans Court, who is AGM Additive Manufacturing Bangalore, AMK Solutions Private Limited Bangalore, who is readily accepted being the chief guest and also as a keynote speaker for today's program. So I'm sure that all the participants will get richly benefited. And my advice to all the participants is to not to miss the sessions and take the sessions seriously, attend all the sessions and see that the learnings are carried to the students. The ultimate objective of the program is enriching the knowledge of the faculty and at the same time moving on, transferring to the students. I'm sure that all the faculty members will take this as an opportunity and see that the objective of the program is fulfilled. So wish you all the best. Good luck. I would like to also thank the organizing committee and also the convener Lakshman Naidu for taking this initiative of this organizing this program. Wish you all the best. Good luck.
Thank you, sir,
Over
for
to
these
Ashwin.
motivating words. Thank you so much, sir.
Good evening, all. Good evening, all. We are extremely honored to have with us today a distinguished industry expert. It's my pleasure to introduce our chief guest, Mr. Shreyans Court, General Manager at AMK Solution Company, an accomplished senior management professional with over 19 years of experience in the additive manufacturing industry, demonstrating deep expertise in metal additive manufacturing, reverse engineering, IP management, design for AM, new product development, business development, laser physics, and machine building. Currently leading a high-performing team of 65 plus professionals with a strong track record in driving strategic initiatives and delivering high impact results, mentoring talent, fostering innovation, and delivering complex projects. He holds a Master of Technology in Material Manufacturing and Modeling Science from the prestigious Indian Institute of Technology, Bombay. And even granted patents in cutting-edge manufacturing technology. He has also additional responsibility as management representative, successfully leading the organization to AS 910 certification, reflecting leadership in quality systems and compliance within aerospace. Please join me in welcoming Mr. Shreyans Court, and I now invite him to share his thoughts with us.
Good evening, all of you. Am I audible? All of
Yeah,
you?
good
you are
evening,
audible,
Mr.
sir.
Good evening, Mr.
Yes,
Shreyans
yes.
Court. Good evening. Welcome,
Okay.
welcome to
Good evening,
the
sir.
program.
Okay. Good. Okay. Respected Principal, Dr. Prasad Sir, Dr. Girish, Education Director, and Dr. Sashikumar, Head of Mechanical Engineering, and Dr. A.L. Naidu, the convener of this FDB, distinguished faculty members, and dear participants. It is a truly honor for me also and privilege to join you today as a chief guest for the inaugural session for this AICTE ATAL sponsor FDP program in the role of additive manufacturing. And the good thing is there you have attached the additive manufacturing as a 4.0. It is a industry 4.0. Good things. Today we are all witnessing the technological transformation driven by industry 4.0, where digitization, automation, AI, ML, and of course, additive manufacturing are the reshaping the industries at an unprecedented pace. At the heart of this transformation from conventional to all these things, AM lies a technology that is only redefining how products are designed and manufactured, but also how entire business models evolve all this particular transformation. For India, if you know all these things, this is the era of opportunity. We have the talent, the industrial base, we have the industrial base also, and the academic strength to not only adopt but also lead the additive manufacturing innovations. However, this requires some strong collaboration between academia, industry, and government initiatives. FDP like this play a crucial role. Rather than FDP, so many engineering colleges have started their coursework also at the basic level also. And then equipment educators, researchers with the right knowledge so that they can inspire the next generation of engineers and innovators. I would also like to emphasize that the journey of AM not just about machines and materials. It is about mindset change. It is about questioning conventional approaches, embracing design change thinking, and fostering an ecosystem of creativity and experiment. As a participant of this FTP, I encourage you to deepen your understanding first of AM process. What is AM? What is the materials requirements are there? What are the industry applications are there? What are the exact requirement? How I can parallelly think about where the futures are there. In the slide also, I will cover all this. What are the disruptive technologies in the additive manufacturing? Explore how additive manufacturing integrate with digital tools like AI. Only AI tools are, we know, ChatGPT, DeepSeek are there. How we can integrate all these things? IoT things are there. Machine learning things are there. And then most important is there data analytics. What are the data the machine, all these particular equipments are giving? How we can predict this particular data for the future conductings are there. And then next thing is this, most importantly, think about how these technologies can be applied to solve real world industrial and social challenges. This is the industry requirement now. There's a huge demand for medical additive manufacturing. And then, of course, there's the industry requirements are there. But if you concentrate on the medical, whole body from the top to bottom, additive manufacturing, everywhere the additive manufacturing parts are there. Okay, in the closing, let me say that the future of additive manufacturing, digital and sustainable, it will be. The efforts being made here in GMR Institute of Technology through this program will surely contribute to building a strong knowledge base and nurturing future leaders in this field. I once again thank the organizer for this opportunity and wish the program with a great success. Thank you. Over to you, sir.
Thank you for your insightful and motivating session. Before we formally close the inauguration, I would like to invite our chief guest, Mr. Shreyan Scott, once again to take us forward by starting the final technical session on this FTP on the topic Introduction to Additive Manufacturing. Sir, we request
Sure.
you to begin the session and guide us through the fundamentals of this exciting field.
Sure. Sure. Give me a couple of minutes. I will start. Can you give me the permission to share the screen?
Yeah, I will do the needful.
Yes, sir. Yes, sir.
Okay.
Yes, sir, yes, sir.
The share button is not activated.
Is it? I can't see the share button activated, enabled. I can see camera and mic.
Yeah. You have to change the.
Yes, sir. Yes.
Now it is activated. Okay.
Yes,
Yes,
Now
yes.
activated
It's done.
screen.
Yes, sir. Now check it, sir.
And
Yes.
then, yes. Can you see my screen?
Yes, sir.
Yes, sir.
Every,
The screen is visible, sir.
okay, okay. I will go to presentable mode. Is it presentable mode?
No, sir. No, no.
Or is it?
Yes, sir. We are able to see.
Okay.
Yes.
It is a presentable mode or
I think you need to choose a different screen actually. When you are making it to presentation mode,
it's,
it is still in the editing mode.
yeah, because I am holding my
Sir,
pen. That's why
actually
it
there
is.
is one icon over there in your computer. Um, you can press that. I mean, right now the cursor is there, right? After that, third icon is there. If you press that, you will be in presentation mode. But I think you are now in the presentation.
That one, sir. That is the slideshow. You can click it.
That's it.
Yes,
Yeah.
yes.
Yeah.
Sorry for inconvenience. So I'm starting with this particular additive manufacturing.
Okay, sir.
This is the first slide. Hope the slide is visible.
Yeah, very much clear.
Yes, sir.
So
Yes,
you
sir.
can note down my contact numbers and the email ID for the future reference purposes also. If someone wanted to contact for the any kind of technical query, you can reach on the me WhatsApp also, and the email ID is available. So this is the almost, I think, more than 70 or 80 more than 80 presentation I have given to ATAL FDP programs. So I'm basically focusing on the key areas of the additive manufacturing. What are the requirement for additive manufacturing? And then some slides I have added for the students, where the future requirement from the industry, where the key requirements are required. So I'll be starting from this particular global overview, and then what will be the present state of this India. Then what are the key government initiatives, including ATAL FDP, and what is the initiatives of government India has taken for additive manufacturing? Then I will, a couple of slides, I will show you about the additive manufacturing process flow. And then I will skip this particular because these slides I have kept yesterday only for ADE only. And then some slides I will more concentrate on this particular design for additive manufacturing, where the industry is required. What are the industry requirement from the student for design for additive manufacturing? Then I will showcase you some case studies, and then what are the some AMAZE offerings are there. Basically, I will start off the introduction of our group companies only. It is a part of ACE Macromatic Group, our AMAZE solution, India's #1 CNC machine manufacturing group. We are started with 1973 with the micromatic grinding, basically cylindrical grinding machines, and then ACE designer for CNC turning machines, and then AMS in 1994 for the VMC and HMC machines. In 2018, we started with the AMAZE solutions. Even also before that, 2002, we have started our own Industry 4.0 IoT solution IT company also, which is basically for machine learning, developing the machine learning data analytics tools also. So 2018, we started with the AMAZE solution with the joint venture between ACE Designer and AMS. Both they have come together and it is started with the AMAZE solutions. It is additive manufacturing from ACE Macromatic Group company, AMAZE solution. Just now I explained these particular things. We are offering the end-to-end manufacturing solution, starting from the design, 3D printing, post-processing, and then what are the material qualifications are there. We have the best-in-class manufacturing setup is also available in the Pinia, Bengaluru. Apart from this, also we have the global presence also available. And then I have already skipped this particular slide. Okay, so I will directly jump to all this particular. What are the scenario? Everybody now chasing to additive manufacturing. if I know correctly, 2002 first machine has came to CMTI in Bengaluru. And then if you take the journey, all these particular things, almost 250 machines are being installed. But if you see from the global AM market perspective, where the global is changing along with this, if you see all these things in 2024-25, it is a 229 billion company. All the AM markets are 24 to 25 billion. And then each year it is growing by 19%. So going forward, this will be the future additive manufacturing. Everywhere the additive manufacturing come into pictures. If you see the current scenario in India itself, it is close to 900 crore market. But if you compare with the global, how much? It is a less than 1%. So still we have the jump, or we have to do so many things in additive manufacturing. And as compared to 19% or 9% in the global projection, what projection we are going forward? It is 18%. In India, every year 18% year and year growths are there, because it is a future. You take any technology, semiconductor, from mobile manufacturing, from this particular medical manufacturing equipment, everywhere India will be the growing all these things in additive manufacturing. We have current scenario in India more than 120 non-metals 3D printer services available, and 2 metal printers are available for this additive manufacturing. And each corner of India, there's a more than 20 plus service bureaus are available. Wherever you wanted to go for your research, PhD thesis, master thesis, BTech projects are there. Every corner of India now metal machines are available, where you can start your study of the new powder development, new material development, new alloy development, where the key areas are there. You can start with these particular projects. So coming back to this particular key government initiatives, if you see, the Ministry of Electronics and Information Technology, METI, had drafted the policy to promote the 3D printing. And then in collaboration with NCAM, Hyderabad, government had established the National Center for Additive Manufacturing. Every corner of India, they wanted to set up this establishment. In Hyderabad, recently, NCAM Hyderabad, we have installed our big size machines, STLR 400 size machines recently, with the twin laser. Whenever you wanted to see the particular facility, you can go and visit this particular facility, NCAM facility also. And then multiple AM technology centers, just like IIT, NITs, even also local engineering colleges also. Recently, we have installed one machine to Manipal Mahe also. Some institute where some discussions are happening to promote this technology. For this, keeping in mind all education sectors, we have developed a small machine, dia 120 by 200 to start your research. Small scale machine also we have developed, keeping in mind all the research and institute. Even also DST has funded 3D printing research labs and innovation. Recently, TDP also has started so many projects also. We have collaborated with the TDP for NITK, IIT Bhilai, and CMTI to develop the technology also, where the industry and academia come together, and then some part of 10% industry will get for give the fund into that particular institute, and then they will develop small what are the industry new requirements are there. That kind of initiative has been taken by DST also. Even EPC Indian RP, starting from the Navy, Aerospace division, and then army based workshops. What are the previously they have the equipment rather than tank, Sukhoi, all these are there. Na? There's a maintenance activities are there, where they doesn't have the CAD models are available. What they are searching for this particular things to do the reverse engineering. Reverse engineering of this particular Russian T-90 tanks, chain block, landing gear of Sukhoi. What are the models are available? We have to do the reverse engineering, make a one CAD model. Immediately we will print it. We will supply to the Indian Army. So huge requirements are there for the Indian Army. Definitely all our new ISRO has collaborated with the startups. We have installed a couple of years back in the prestigious institute of the ISRO itself. One ISRO again STLR 400 machine, where they are continuously using our machine for the satellite components. And definitely government backed incubator nurtures are available for the 3D printing parts to launch the vehicles also, starting from the Bellatrix, Skyroot, Agnicol, Cosmos. What are the startups are available with the government back? They are going for the 3D printing parts. So coming to the main topic, all these things are there. What we have learned in the engineering colleges, starting the 4-year engineering BTech or 2-year MTech or 5-year PhD programs are there. We'll start with this particular, the word conventional manufacturing. If you know, we know Stone Age, we know castings, we know forging, we know extrusions, we know machining. And whatever this pen are there, if I see this mouse is there, once I started the design in the industry, I will keep in mind what are the manufacturing processes are available. Oh, I will go for forging this coin, or I will go for the extrusion, I will go for machining. Nobody thinks about the 3D printing. It is a forming processes are there whatever the lattice structures I can provide in this and more complex job with lightweight, I can produce this particular pen. So the next area conventional is to additive manufacturing method. So keeping in mind all this particular conventional manufacturing, we have to think about what are the disruptive technologies. What are the coming disruptive technologies? IoT. Everybody knows cloud, IoT, internet, renewable things are there. Cloud technology, energy storage, batteries. Now everybody is chasing for batteries also. Then advanced materials, next generation, mobile internet, robotics, and then autonomous vehicles, ADAS technology. All this disruptive technology, there's a one technology called as 3D printing also. It will disrupt the market. I will tell you again and again, what are your design thinking, your student, the requirement from the industry, from the student is how effectively out of box. I will again use the word out of box. How the out of box you can think the conventional manufacturing design. I can change to more complex lattice structures, which can be only manufactured by additive manufacturing. So my next slide, couple of slides will be the out of box thinking. In India, I will tell you, we have more innovations. Wherever the problem will come into our regular lives, we will try to find the solutions. I will tell you again, wherever in each stage we facing the problems, we will find the solutions with the effective way. That is also called as our industry or our life Jugaad technology. The same thing I am wanted to correlate with these particular things. Whenever we will think about out of box, that is called as design for additive manufacturing. This is out of box thinking, then Jugaad, then it will convert to design for additive manufacturing. How I can convert conventional manufacturing. So your mindset is required design for out of box. So this is the basic slide I have kept. Everybody knows all these things. This is starting from the binder jet technology, material extrusion, powder bed technology, wet polymerization, DED, material jetting, and sheet lamination. But if you see this or this, powder bed technology and DED are more famous because of more adaptivity, and then both the technology powder bed and then DED giving the commercial product to the industry or end applications. So we are talking about this particular selective laser melting and then EBM also and some electron beam also. I will not go in detail for the technologies because almost every internet it is flooded all these things. More focus you can focus on the powder bed and DED. It will be the industry requirements are there. So this is the process chain. Hope I will try to explain this particular process chain for the powder bed technology. Powder bed fusion, PBF. If someone asks in the interview questions, what is the PBF or laser powder bed technology? It is a long form of laser powder bed fusion technology. Basically, laser will come from the top and then layer by layer, it will start melting the powders. Whatever the powders are available in the market, all weldable powders, all weldable powders. You starting from the titanium, inconel, aluminum, iron grade powders. What are the powder particles are there? It will lies on the platform. I had to give the CAD model to the machine. It will slice it. This pen I had to print it. It is printing like this or horizontal. Whatever the positions are there, the slicing will come into picture. And then laser will start melting that particular area only. Step by step, what are the platforms are there? It will go down. Again, the next powder will come. And then after end of the process, we have to up the platform, remove surrounding powders. We can reuse the powder and then the part is stick with this particular platform. We have to do heat treatment and wire cut. So starting from this, we have to do the CAD modeling. I will more focus on DFM because it is a key strength for additive manufacturing where we have to put some topology optimization, lattice structures and design for additive manufacturing. If you go for the reverse engineering reverse engineering, where the some accident will happen and doctor will scan your body. It is called as DICOM fall. Note down all these things. It is a medical terms are there where the DICOM fall. They will do the DICOM file CT scan. They will send it from Hyderabad. Some biker has got some road accident and some kind of orthopedic problems are there. They will scan the DICOM files. They will send it to Bengaluru. Immediately we will scan this particular DICOM file. We start slicing. We'll print it and then we will use this particular ready-made orthopedic implants within 1 day. This is the beauty of additive manufacturing. So we have to start with engineering and software. I will more focus on these particular things. What are the key things are there? You have to see the opportunity. How I can put myself rather than this medical or design CAD modeling expert or FES simulation expert where I had to focus and then I will contribute to the industry. If you see this is a process and see the other side of the coin where I can see the opportunity. In the metallurgy itself, material characterization, one experts are required for chemical analysis. Who are the finding out the alternate materials are there. So metallurgy expert, design expert, medical engineering experts, and then definitely the process parameters are there. How laser physics is more important because everywhere we have to melt the material with the it is liquid state. Melting will happen, it is a liquid state and cooling will happen. So what are the process parameter? How can play? How I can effectively use the thermodynamics? What is the specific heat capacity of material? How much thermal conductivity? How much heat I had to give to that particular material where I can get the good mechanical properties. So then the printing, production supervisor, production handling, machine handlings are there. And then IoT things are there, machine learnings, where the closed loop monitorings, which are the more expert in this particular coding kind of things are there. And then defining AI tools to monitor the program kind of things are there. And definitely there is a post-processing are required, wire cutting, vacuum heat treatment, sand blasting, and 5-axis machine also. I will not go too deep all these things. This is the qualification process. If you see, I will start with the design validations. This example you can see, this is the seat belt, four-wheeler seat belts, where the previously 8 components are there. It has been manufactured one to one single components. It is a design challenge published by the company, four-wheeler company, where all the students came and they have put their design also. So design validations are required. This is the yesterday's slide. Specifically, I have put for the aerospace application. Some material qualifications are required. All these things are there. I will not go to all these particular AMS standard, ASTM standards. Everywhere the standards are available for this particular material qualifications. Some process qualifications are required also, where you can see all these things. What are the printing things are there? How can I extract the mechanical tension coupons? Then how I can improve? How I can give the knowledge to these particular things with the heat treatment, process parameter, and post processing to part qualification. What are the part qualifications are required? We have to do all these things. This is all the aerospace requirements are there, where the documentation, traceability, and then certification and regulatory bodies are requirements are there. So coming back to this main topic, I think some slides are jumbled, all these things. This is the main topics, what I have talking about the OOB, out of box thinking. So put your more concentration on these thing particular slides. What you understand all these things? This is the 2-minute Maggie. The problem is we have made the Maggie in 2 minutes, but it is a hot conditions and I had to eat very fast. So they have put the fan. So there is a solution is there. So next things, shower caps. If you see all these things are there, the baby is there. They wanted to put the shower and then this shower cap has been designed. So wherever there is some requirements are there, we have to put the out of box thinking. Same thing it will applicable for the design for additive manufacturing. How effectively you can design for additive manufacturing. Then
Sir, you are in mute, sir. Sir, you are in mute. Hello, sir, you are in mute. Hello, sir, you are in mute. So please unmute yourself. Yes, yes, now it's clear. Okay, you can go ahead, sir.
oh, so how many slides I missed?
Yeah, yes, last slide only, sir. Only last slide.
This slide? Okay.
Yes, sir. Yes, you can share the screen again, sir.
Okay. Can you see my screen?
No, sir. No. You can share the screen again.
Again.
Yeah.
I have to share.
Yes, sir. Yes, sir.
Okay. Okay. Can you see my screen again?
Yes, sir. Yes, right. You can go ahead.
Oh, okay. So I will go back. This slide you have missed, I think. Correct me?
Yes, sir. Yes. Right.
Okay. So if you see all this particular out of box thinking, where the requirement is Maggie is there, and then it is a 2-minute Maggie. He has to eat fastly. But if you see, they have put this particular fan. So it is called as out of box design. How I can correlate this out of box design to design for additive manufacturing. Same thing, same conventional manufacturing part, how I can convert by putting out of box design. So there is a special workshop we are conducting in the AMETS itself. 1-day workshop or 7-day workshops are there, where industry train the trainer, what is called as faculty members are there. We are giving this particular training. How you can teach your student for this design for additive manufacturing kind of things are there. Some another case studies are there. If you see the baby shower cap, the problem is there. We have to put some baby shower, but we have to design some. There's a solution is available. Wherever the problem will come, the solutions are there. That is, I wanted to correlate this out of box thinking to design for additive manufacturing. Same thing is there. Eye drops are there. If you see wherever the problems will come, the eye drops they have designed very beautifully. The same umbrella is there. Multiple use are there. I will give one example of this. If you know this four-wheeler car, my design is so not so good, but you can understand where the AC will come. There's a front ACs are there. There's a back ACs are there. Some top ACs are there. So what are the AC will cooling will happen? Can I see my slides? It is more important.
Yes,
Slides.
yes, sir. Yes, sir. Yes, yes,
Okay,
yes.
okay, good, good. But nobody thinks about these particular things. What are the ACs are coming? Always AC will come from the top to back side, from the front to back side. Same thing. One person out of box thinking in the Daimler. What they are designed the gear shifter knobs. Gear shifting. What are the gear shiftings are? Or the some handles are there? What is the steerings are there? What they are designed the beautifully, the AC vents they have put in the gear shifting knobs here. Now, what are the AC will come here? It will go like this. Multiple use, same thing. One use tie, multiple use, same thing. They have done this particular gear shifting knob to cool the car more effectively. Even also steering, they have put some AC vents also. So you can feel the AC. Why? Only possible by additive manufacturing. I will see some couple of slides also. I have put this particular gear shifter knob picture also or not. Same thing you can see. The particular slide, these slides I have kept for what are the ATAL FDP programs are there, where the student can see the out of box thinking level for the additive manufacturing. So if you see all these things, this is the seat buckle. This is the student challenge they have put by GM. Then see the multiple designs. Each student different mindsets are there. If you see all the students, they have kept all these things. One design has been selected for the design for additive manufacturing, where you have to see the design for the improvement functionality, design for minimum material use. Definitely this material 8 component into one single component, the material they have reduced also, and then functionality also. So these 8 component they have reduced to 1 with 40% lighter. But if you see, these are 20% stronger. This is the design challenge. But now I am here. I am a industry person. I will always talk about the cost, money, how much money I have saved in these particular things. By these conventional components, I am putting 1 rupees. Take it as 100 rupees. But I am spending this particular 120 rupees. Where is my cost? I am putting 20 rupees extra. So I am an industry person. What I can think all these things. Any answers? If you see, I will tell you, this is the 8 components. So 8 different suppliers located in 8 different cities. And then what is called as supply chain issue. If you see all the supply chain issue, whatever in case one supplier has shut down his shop, then I had to depend upon the 7 different, and then my whole assembly will hamper. If you see every 1 minute or 2 minutes, our machine is coming, CNC machines are coming out in the chains. If the one supplier has broke down all these things, we have to keep the inventory continuously. The inventory cost will be there, and then supply chain is there. If I put one single machine, where the build plates, I can put multiple these parts, more than 100 parts here in this particular things. One single machine, I can print all these things. That is called as supply chain. And just in time, I can print. I can't depend on this particular operations, n number of operations, sheet metal, bending, cutting, all these things are assembly, nut bolts, design restriction, nothing is required. So you have to think about this, all this process of, it is a very vast subject, design for additive manufacturing for students. So we have to do the consolidations, design for consolidation. If you see, this is the fuel nozzle for the G also. It is a supplier last 7-8 years, it is flying now. And then how we can consolidate it, the assemblies. We have to think about the machine design you have learned, design stacking, design tolerances, plus minus tolerances are there. How I can stack up analysis, design stack up analysis, how you can reduce down all these things are there. So I will start with some case studies also. This is the very beautiful case study I will tell you. This is the conventional manufacturing manifold. It is came from army base workshop. From the some tank applications are there where they didn't know the material. They didn't know the material. So what we had done, we have cut down some material. We went for some IIT, some chemical composition, alternate material. So metallurgy come into picture. First thing, we had done the reverse engineering of these particular components. What are the CAD models are there? So reverse engineering experts are required for this particular, who knows the CAD modeling, all these things. Then material experts are required here to identify the material and then comparative this material, this chemical composition, this is missing, this is missing. Okay, I can give same mechanical property for this. Now third will come into picture for design penetrative manufacturing. So this is not required. This is conventional manufacturing. I can go for conventional manufacturing, design the drilling, tapping, all these things are there. Why should we go for design for additive manufacturing where volume is 336? I can reduce down to 55 cc only. And then if you go for conventional, same part for printing, it is a 28 hours. I can print it in 15 hours where the design for additive manufacturing come into picture. So how beautifully they have designed, see. So 80% part volume they have reduced, 46% printing time they have decreased, all these things. Okay, there is a key challenges are there. I will see key challenges means there's the opportunities are there for industries, for student. This is challenge for industries. This is opportunities for students. We require material experts. There is some limitations for the sizes are available in the machines, but definitely we are going for now 1 meter by 1 meter cube machines with multiple lasers. Now in China, they have established the 64 lasers. Our lasers is 2 lasers they are printing, but 64 lasers continuously. So productivity is increased. Skilled workforce, definitely I have specifically prepared a couple of slides for you also. What is the skilled workforce are required? Some dimensional accuracy. I think principal has raised these particular things for the surface finish. Correct me. What are the surface finish is somehow as printing condition we can achieve 5 to 6 array. But definitely there's some processes are there, post-processing processes where we can improve below 1 array. But we can't improve all this particular. There is some limitations are there where we will go for conventional light cut machinings. Wherever the assembly parts joinings are there, we can improve the surface finish also. Definitely high equipment costs are there still, but so many powder manufacturing, so many machine manufacturing coming into make in India process also. So definitely it will go down. High equipment cost also. This is the case studies. The case studies will be started now. Some case study I will start. I think I have couple. Check. So okay, I have another panel. So you can see the these throw machines. we have installed one machine in ISRO. The how effectively the transparent, if you see there's a tensile coupon behind these particular things. This is a transparent wall they have designed first for the noise suppression for the satellite part conductors. It has been printed in our machine in ISRO VSSC. Along with this particular, they have put the tensile coupon to check the chemical composition, mechanical properties, all these things are. How tiny parts they have printed, you can see with the some lattice structures with holes, all these things are there. It can be possible by additive manufacturing only. And then everybody knows about the Gaganyaan mission, human space, all these things are there. If you see, first time our 4 crew members are going for the Gaganyaan missions. We are jointly hand with the HSFC to print this particular cruise sheet brackets. Conventionally, they are doing by laser welding, sheet metal bending, all these things are there. More than 17 sub-assemblies are there. So we have splitted to 17 sub-assembly into 5. And what you have seen all these things, it is a where the cruise sheet assembly we have printed. The person will sit here and then they will go for the Gaganyaan mission. So this is the key challenges are there because you can only see the problem and we have printed. But before that, we have put extensive efforts for the simulation. More than 3 months we are running the simulations. More than 3-4 iterations we have failed to assemble the parts also. Extensive tensile and mechanical properties we have tested. Once it has been qualified, it took us 1.5 years to qualify all these things. Now, once we have qualified all these things, the more orders are coming and then the good this there. AMES is printing this particular human seat model for the HSFP, first Gaganyaan mission for the mission. And then if you see previously Gaganyaan mission, no human has flown. Now human is flying all this particular, all this Gaganyaan. They wanted the windows to see what are the outsides are there. So what are the windows are there? This viewports are there. The casing we have 3D printed. How many sub assemblies are there? You can see conventional. We have printed in the one single assembly with the alternate material that is titanium alloy, where it can withstand all these particular extreme end conditions. Some case studies are there for this particular differential housing. EV bike we have printed with just in time with the 3 months we have printed the 70% parts from the EV bikes and it goes for the all Bharatmala trip also. Some tool holders for the machine tool industry. What are the, you can see this is millions of parts we are printing. I just wanted to highlight these particular things from the automobile to space to all the tire industry, tire modes. What are the suggestions are there in the tire modes? All these molding tire molds we have sites we are printing millions of parts. I will say the comment like this. All over 90% in India, tire sites has been printed by 3D printed only. Only few tire manufacturing, they are going for conventional manufacturing. The industry has adopted tire manufacturing mode is 90% by 3D printing only. Some case studies are there. Yesterday I have put for the code plate assembly. This is a semiconductor industry. I will tell you again and again, semiconductor industry. Previously, it is a brazed part. One single 3 parts are there, where all the liquids are flowing. We have designed this particular to one single assembly and one single part, 1, 2, 3, 4, 5 parts we have printed now, and it is going on continuously. All these things. Some jet engine parts we have printed for the aerospace applications, where the high temperature applications are there. This area, if you cut down, you can see 300 micron walls or holes we have printed, where the fluid is going continuously and it will serve the purpose. Only by additive manufacturing can be possible. So we have to think how effectively we can use the technology. The technology is available, how effectively we can use this particular technology, where we have to remove our barriers for conventional manufacturing constraints. Forging constraints are there, casting constraints are there, machining. It can be possible additive manufacturing, how effectively we can redesign. Some engine components we have printed. This is the engine for this particular aerospace application. It is a discarded engine. Again, I have used the word discarded engine. The Latin America, one company, they have purchasing the discarded engine and they are going for the power generation or energy applications. Power generation they are using. What are the struts are there? It's a big struts. One strut is close to 7 to 8 kg thrust are strut are there. So we have printed in the 3D printing. The challenges is in Conal 700. So where the again engineering will come into picture, where the how I can reduce the residual stresses behavior, how effectively I can give the energy density, how I can preheat the platform before printing, how effectively I can give the preheating from 200 to 300 to 400 to 500 degree, where the residual stresses will decrease and then directional solidification will happen, all these particular things. Some jet engine component previously in my career also we have printed some 30 kg, 40 kg thrust jet engine also. And then some patent also we have filed for the jet engine. I will skip these particular things. Some lattice structures, you can see there's a limitation of 400 by 400 there. But how effectively the corner we have placed the 524. If something limitations are 400 by height is there, how I can tilt it longitudinally. And then dummy walls, you can see these dummy walls. This is not part of the design. Because of this particular support, lattice structures are there. We have to print these particular things. We have purposefully added 200 micron dummy wall. How effectively we can use this particular lattice structure? It is again flying to I think VSSC or URSC. This is the URSC part where the aluminum ALS at 10 mg material with lightweight we have printed this particular parts. The again good case study is there. It is a 110 sub-assemblies are there. Sheet metals. What they are doing for the radar signals. Radars are there, no? Radar signals. It is a 3-story wall components are 1, 2, 3-story walls are there. And it is a radar sensing and then leak proof is requirements are there. Conventionally, they are taking the small sheet metals, they are welding together and they are making all these things. The challenges is there. It required skilled labor force and the time. More than 3.5 months to 4 months are required to do the conventional manufacturing for one single parts. We have assembled 110 sub-assemblies into one single. And we are effectively using all these things. This is the good case study. All these things are there to integrate this particular for defense applications. Some VSSC applications are there for the CNC machining, conventional manufacturing. It is taking so much times. We have printed in the 70 hours. It is again a space application, ALS at 10 mg. This is the collimator for space application where you can see 300 micron walls are there along the 100 mm length or 300 mm length. Two varieties collimators we have printed. You can see all these walls are there where the signals are going. Not possible without the design change, conventional. We have printed in 40 hours, 4 parts. No leakage signals, reduce the lead times. And then this is the proud thing are there. Chandrayaan 2 and Chandrayaan 3. You can see this is the national emblems are there. What we have printed. Within 1 hour, we have printed all these things to give this particular if the rovers are there, it is moving in the Chandrayaan, there is no atmosphere there in the moon. And what are the impressions are there? It will stay lifelong. So what are the emblems are there? We have printed in our machines. This is our machine offering STLR 120, 180, and 400. I will share this presentation to you also, where you wanted to do some kind of prototype development, some training kind of things are there. Always you are welcome to see our facility, where the small size machine to 400 size machines. In Hyderabad, we have more than 3 machines now. Next to your Hyderabad, with the DMRL, MCME, Military Engineering College, and NCAM, we have the 3 machines are available. Where you want to see this particular facility, you can go and visit this particular facility also. This is the career opportunity. Yesterday evening, I have prepared this particular slides. I think one slide I have prepared for this. I already explained we require design engineers, EFM engineers, who are the expert in the topology optimization, lattice design. This is a different softwares. Huh? Don't confuse all these particular things. CAD software designers, where they can design the CAD software, they can put the topology optimization. Over and topology optimization, they can put the lattice structure design. Knowledge of LPBF. Mechanical designer engineers are required, where they can know the GD&T, who can design them our machines. Machine designers are required, who know all these things are there. Some operator technicians also required, there is a career opportunity for AM. Some engineers are required for the Magics and NetFab. This is specific softwares for additive manufacturing are there. Some production engineers, there is a requirements are there for the skill workforce. Some quality engineers are definitely required, who know the support removal, heat treatment, CNC finish, short blasting, post-process engineering, who know the quality NDT techniques, who are the qualified NDT professionals, who knows QA and QC, difference of the QA and QC, how we can reduce quality assurance with the quality conformance. Quality inspection engineers are required, CMM, 3D scanners, CT scanners, who knows all these dimensional tolerances inspections are there. Definitely, there is a huge scope for the metallurgy engineers who know the microstructure analysis and all these kind of testings, develop the new material, new alloys, who can suggest the alloy development, adding the niobium in the inconel, high entropy alloy developments are there going on. Some CM247 materials are going on, all these particular things, where the huge requirement for this particular metallurgy. Then definitely sales and AM roles are there. Who knows the technical of BTech and they had done the MBA kind of things are there. Definitely some business developments are required. I already pointed out some reverse engineering specialist are RE who know the scanners, who can give the point cloud data, he can generate the reverse engineering kind of things are there. I will share this particular slide to sir also, where you can start your career along with if you are interested in additive manufacturing kind of things are there. You start with all these things. Some installations are there. I am coming to the end of the slides. I think I have another 10-15 minutes. So you can see DMRL, we have installed 400 by 400 machines. In ISRO also, we have installed two laser 400 by 400 machines. Even also education academy also, we have installed some machines. Where Manipal, we have installed small machines, where they want to do more R&D on this particular medicals. They want to do on medical mandibular implants, dental copings, maxillofacial, and then implants or hip or knee joints are there. So small education machines with minimum value, we have installed all these things with the IIC also some small instruments we have installed. Just now I told you military engineering of electronics and electronics, it is again in Hyderabad, where we are installing all sort of additive manufacturing processes, not only LPBF, some DD technology, some LPBF, some plastics, some polymers, LPBF, and another post processing. Overall, end to end, we are installing in MCME Hyderabad. Same IIT Kharagpur, IIT Bombay, IIT Bhilai, we have installed the machines. So education wise, we have installed all over these particular things. Small machines we are developing, keeping in mind for additive manufacturing for dental labs and education itself. So this is the last slide. Over to you, sir. Hope I have kept more than 10-15 minutes specifically for the question and answering, because rather than this particular technology, this is the first presentation. I doesn't want to stress too much. Then to be frank, I'm sitting between you and India-Pakistan match also. So I'm waiting for your question and answer. Over to
Yes,
you.
thank you, sir. Thank you for your valuable session. And thank you so much. Yes, dear participants, you can ask the questions and your queries in the chat box. Yes, it's open to you all.
73 are there participants.
Yes, any of you can ask your queries through chat box.
Oh, I can't see the chat box.
Yes, sir.
The chat box is not visible.
The chat box is not visible. Okay, you can ask directly,
Yeah.
sir, questions.
Okay. Only members of team have access to
Giving the
the chat.
permission, chat box.
Okay. Any questions?
Yes, dear participants, you can ask the questions. You can raise your hand.
I'm purposefully keeping all ATAL FDP programs 10 minutes, 15 minutes. And there is a full of questions are there, starting from the scratch, all this technical, who wanted to do the other careers. So I want more questions here. Wherever the interaction sessions are more important for me now. Yeah. Okay,
Good evening, sir.
Shantaro is there. Yeah, good evening.
Sir, I'm Dr. K. Shantarao, Associate Professor from
Okay,
Department
good.
of Mechanical Engineering from GMRIT.
Oh, good, sir.
So the session
Tell
was
me,
very
sir.
very useful, sir, because you have
Okay.
thrown some very good insights how we can encourage, improve our career in this additive manufacturing, because it being a buzzword in nowadays. So
Yeah.
what are all the prospectives? I can say, like what are the prospectives, or what are all the options which we our institutes, like our GMRIT is, though it is an autonomous institute, we want to advance our presence in the entire India, I can say, or the worldwide. Okay.
Okay.
So what is that we can collaborate in what way? Our institutes, like not it is not at par, though we are trying to being at par with the IITs or NITs, but there are some limitations for us, and I don't say limitations, I can say it is challenges here. So in what way we can proceed so that we can collaborate with industries like you, so that we can enhance our presence in the entire country, sir. So
Sure,
if you can
sure.
throw some light on this, definitely we can collaborate, and we can I can say
Sure.
because AICTE and our Make Up India or Make in India has come up with some is asking for proposals, so that collaborative proposals from between institute and industry will definitely enhance, I can say, the presence of both the I can say, like, mutual understanding between industry and institute here. So in that
Sure.
perspective, what are the initiatives from your side, sir? If you can throw some light on that.
Sure.
Because you have shown some case studies, like you have installed in IITs and NITs. But is there any institute which have installed in, like our institute, like autonomous institutes in
Yes,
our
yes.
nearby
Yes.
Visakhapatnam or some other things?
Okay, sir. It is a good question, sir. Everywhere it is asking how we have to start, because we have seen this particular things. What will be our approach? How effectively I can install or some 3D printing career development or some kind of things are there in the additive manufacturing. So I will tell there's a three approaches there. I will tell you my struggle. All these things are 2006 once I started all this 3D printing. There's a huge resistance are there because there's a no awareness. First thing, once I learn all these things, 2008 onwards, I started going to each and every academia where the awareness session is more important. Then I realized the equipment cost is higher. Nobody will go for this CR machines to install and they will start the academia. So what my suggestions are there, na sir? You start with the some coursework for this particular things. Small courseworks. There's a starting from the design courseworks, metallurgy courseworks, and then small plastic printers are available in the markets now, where the industries, plastic manufacturers, they are collaborating with this particular institute, autonomous institute, where they will put your machine for this particular leasing period or 6 months, 1 month kind of things are there. You can 1 year you can use this particular things machine. Hello.
కంప్యూటర్ ఏమైనా నేర్చుకున్నావా ఫిజిక్స్ ఏమైనా నేర్చుకుంటున్నావా నేను సబ్జెక్ట్ ఫెయిల్ అయిపోతాను
Okay.
Yes, sir,
Sorry,
you can
there is some
continue.
disturbance.
Yes, sir.
Yes, some
sir,
disturbances are there.
Yes,
So,
you can continue.
so
Sir.
some plastic printers you can start with these collaborations. There is a in second stage. Once you know all these things, some little projects you have to do. Once you have some case studies are available, we will jointly, there's a industries are there, academia is there, and their government proposals are available. Each and every day some proposals are coming where you can apply for this. Idea labs are there. Recently we have went to Ramaya Institute where they have approached for the AICTC idea lab kind of things are there. They have put some plastic printers. They have started with specific things. I will guide you also where we have to apply, where you have to go for the industry, some supports where industry can put the 10% of this whole project. And then we will support you for the installation of idea labs. Starting from there's a 197 instruments are there total. Then we can step up to next level of 3D printing. So this is the approach there. We have basic guidelines we have defined. From 2018, I started with this particular industrial academia guidelines kind of things are there. Once you can come to, or you can ping me in the my email ID, I will set up these particular things, how you can step-by-step approach is more required. Second thing is there, I will tell you, initially we have initiated with these particular things to each and every engineering colleges. There is Allied universities is there. So many Geetam universities there, where 1 year, first year, there's a common subjects are there, all BTech students, where we will start the 3D printing programs with minimum charges. Minimal means minimal charges. And there is some maths calculations are there. I will share with you also, where the awareness sessions from the starting of this particular initial first year itself, one coursework we had to define. I had the coursework materials are also available, and some fees we can nominal charges we can put in the student also, where they will start initially engineering career itself the additive manufacturing. That way we can start from inside out rather than depending upon the government kind of things are there. We will start, and then there is some specific guidelines are there. I will help you for these particular things. Hope 50% I have answered, 50 to 70% I have answered your question, sir.
Yes, sir. Yes, sir. Thank you.
Okay. Okay.
Thank you, sir. Thank you.
Okay, thank you, Chandra sir.
Any questions?
Hello. Mr.
Hello.
Yes, sir.
Also, this is VG brother from PD Engineering College, Gulbarga.
Okay, good, sir.
So recently we have applied for the IDEA lab, and we have got
Oh,
sanctioned
good,
the
sir.
IDEA lab. Okay, sir.
Oh, good, sir.
And
Okay.
now we want to procure some 3D printing machines. Okay.
Okay, good, sir.
And I am we are in a confusion what sort of machines, whether we go for plastic machines or metal printing machines, and where to get it, whether we have to go for gem portal, all those things. We are in a confusion. Can you clarify
Yes, sir.
about this,
Yes.
sir?
Yes, sir. I will give you all these details. Chat box is there. Can you enable the chat box where I will put my email ID.
Yes, sir.
So
Yes, sir.
there's a lengthy process is there, sir. Idea
Okay.
Labs. Once you have got the sanction from this, all these things are there now.
Okay.
I think there's a two processes are there. Either you have to go with Gem portal, or
Yeah.
else three quotations are there. Three quotation
Okay.
out of three quotation you have to submit. One quotation negotiations are there. First you have to fix your requirements.
Yeah.
Either you have to go with polymer, FDM printer, or basic
Okay.
level of SLA printers, plastic
Yeah.
printers.
Yeah.
Along with these plastic printers, there is so many initial requirements are there. Small, even also ACE Micromatic, we have developed a small lathe machines, small
Yes.
CNC machines for the education also itself. There
Yes.
we can pitch also, and then in the second stage,
Yeah.
once you are qualified or you have the confidence level high, second
Yes.
stage itself there is another government proposals or DST proposals are there where we can apply for metal, because metal cost always come into pictures. It is a costly
Okay.
process, and then once you install all these things, you have to get some ROI, or what are
Okay.
the investments are there. We have to how we can give these particular things return on investment. So I will
Okay.
guide you all these things, sir.
Okay, sir.
You can connect with me also. Initially, I have given me my email address also. It is a
Okay.
sreyanskot at am-ace.com. And then
Okay.
I will step by step, I will guide you, sir.
Okay, sir. Thank you, sir. Thank you
Start
very
with
much.
the plastic printer, sir. Start with the plastic
Okay.
printer, sir.
Right, sir.
It is
Thank.
in
Yes.
Sir, I
1,000
shared
rupees
all the
only.
details of SAR mobile number and email ID in the WhatsApp chat, sir. You can check all the
Okay.
participants. If anyone
Okay.
Yes,
want,
sir.
you
Okay.
can contact to sir.
Okay.
Sure,
Thank you,
sure,
sir.
sir.
Thank you very much.
Okay, great. So any other questions
Any
from the participants?
students, I want answers, questions from you. Any questions? Don't hesitate. It is a foolish question or single all questions. Once you are clear your mind only, you will jump into the well to river, river to sea.
Yes, you can unmute and you can hear the questions if you have anything, any doubts.
Any
Yes, this is the
questions?
last part.
I can see 74 members are there. Students,
Yes, sir. Okay, sir. Thank you, sir. So
uh,
yes, Ashrita, you can. I'm handing to you, Ashrita. Yes.
Thank you, sir. We sincerely thank Mr. Sreya Sport once again for the wonderful session that has laid the groundwork for our learning in this program. We appreciate your time, effort, and valuable insights, sir. Thank you so much for this session.
all of you, thank you, all of you. I will be available on the mobile and email also. Whatever your minds in future also, you wanted to collaborate, you want some training, train the trainer, expert trainer, you staff also wanted to do some kind of training for additive manufacturing. You just me ping out, we will arrange for all this particular training. Thank you once, all of you. Thank you. Bye bye.
Thank you, sir.
Okay, sir. Thank you, sir, for your
Thank
wonderful
you.
session.
Thank you. Bye
Okay,
bye.
sir.
Good
Great.
night. Good night. Good night, all of you. Good night. Bye bye.
May I have your attention, please? So this is to inform that the next session speaker will join at 8 o'clock, 8 p.m. And we are going to start the session too at 8 p.m. Thank you.
Yes, the next session will start at 8 p.m. So the second speaker will join at 8 p.m. Yes, all of you can take break 30 minutes.